Good evening, folks. Tonight we target the upper atmosphere and aim to simplify a recent shift in the field and communicate the discoveries and implications of those discoveries in a way that you can understand. When we discuss the upper atmosphere, this isn't where the clouds are, this isn't where the airplanes fly. Above the troposphere where we live and the stratosphere where the ozone layer is found, we find the mesosphere and the thermosphere. From the ground up, we live in the troposphere. Above that is the stratosphere, and then the mesosphere and thermosphere sit above that, with the thin exosphere even higher, followed by the plasmasphere and Earth's magnetic field. The ionosphere we frequently discuss as being so important to space weather spans from the mesosphere up through the thermosphere and into the exosphere. Now, given the widespread understanding of the sun's influence over the ionospheric layers, especially during solar storms, which also strongly affect the ozone layer, it may seem elementary that the sun should be a major controlling factor of the major climatic phenomena of those layers. However, despite everything we know about the sun's effect on ionospheric density, electric currents, and the global electric circuit forcing of that upper layer modulation throughout the total vertical atmospheric column, the sun has been conspicuously absent from most mainstream discussions on numerous aspects of the mesosphere and the thermosphere. Instead, the temperature, the key phenomena, they have been said to be tied to carbon dioxide levels, like we hear about with climate change when they talk about the weather down here at the ground. Except, in the upper atmosphere, CO2 is actually supposed to have a cooling effect. And despite the peer-reviewed literature in the journals existing for years, this year, things began to take a huge turn. The superrotation discovery, one of my favorites. Superrotation of the thermosphere refers to the fact that it goes faster than the atmosphere and the ground below. It is actually driven to higher speeds, and that was something that couldn't be explained with internal dynamics from below, and which caught the attention of the entire field. And if both the thermospheric superrotation and the density modulation is driven by space weather, especially when there is added particle coupling with enhanced solar wind like coronal mass ejections, and during magnetospheric compression on the sun-facing side, when radiation belt particles are injected into the upper atmosphere, then it should have been no surprise when this year the foundational examination of long-term thermospheric temperatures revealed there is no CO2 effect. Oh, the CO2 is there, to be sure. In fact, the increase in the thermosphere is nearly 30%. This is not insignificant, and according to the same mainstream molecular chemistry used down here at the surface, those interactions up at the top of the sky should have forced a 21% decrease in temperature, and instead, the temperature is 99% accounted for by solar and geomagnetic conditions. And while this came as a shock to an enormous percentage of the field, it's not so unexpected when the density and superrotation of that atmospheric layer are controlled in the same fashion. FYI, this is the thermosphere temperature record, graphic available from Dr. Tony Phillips. The temperature trends perfectly match solar cycle forcing over the 11-year sunspot cycle, even matching the cycle amplitude, cycle 24 being a weaker one on the sun. So, let's come back to this pretty color chart and blank everything to white. Now I'm going to turn the troposphere, stratosphere, mesosphere, and thermosphere blue. This chart now shows which layers of the atmosphere were thought to be controlled by space weather and geomagnetic conditions, in white, and then the ones we are told are controlled by CO2, in blue. Ozone appears to be somewhere in the middle because both pollution particles and solar forcing have strong effects on that layer. Now, as one might expect with ozone and ionospheric modulation being familiar realms for the sun, the thermosphere is on the chopping block. There's really nothing left at the thermospheric layer. The temperature, the density, the superrotation, not to mention the numerous other papers on both the currents and neutral winds and how they're strongly modulated during enhanced solar and geomagnetic conditions. We're going to have to turn that one white. Now, we move on to the mesosphere, and here, there is an increase in CO2 and a drop in temperature. And here we're focused on the changes in the polar summer, the vertical dynamics, and the echoes. There has been record activity in those dynamics, and the mesospheric summer radar echoes. These echoes are driven by the interactions of electric charge, dust, and ice particles. And while what I'll call academic suspicions of solar and geomagnetic control over those radar echoes have been thoroughly brought into the forefront this year, also, an overall positive trend in their occurrence has been logged. It's the part that's not accounted for by the solar and geomagnetic conditions. And that part is where, even today, they make a considerable error in presuming it is the slightly lower temperature of the mesosphere. They say that the increased CO2 and lower temperature could be freezing more water into ice, and since ice is one of the ingredients of those radar echoes, this could account for the increase. However, the mesosphere is the coldest part of the atmosphere, which means there's a big problem for the CO2 theory. With temperatures of -100 Fahrenheit being a regular occurrence, how does this freezing extra water idea manage to survive against basic logic? You know, the stratosphere ranges between -5 and -60 Fahrenheit, so it's safe to say that by the time it gets up there, it's frozen, and that a slightly lower mesospheric temperature isn't going to create any more ice than there otherwise would be. No, the little colder temperature on top of -100 isn't going to cut it as an explanation here. So let's go back to an ignored paper from 31 years ago, the hypothesis about electron density profiles being controlling in the mesospheric echoes, a process we know today to be wholly controlled by ionospheric currents modulated by the sun. It was so ignored that 9 years ago, the idea had to be reintroduced with the full implications of solar and geomagnetic control, and it was received about as well as the first one. Now, it's no longer a hypothesis, an idea, but there's mathematical and observational evidence that this is exactly how it works. Auroral energizing synchronized with the echoes confirmed yet again represents a solid argument against the CO2 causation in the polar summer echoes. And just like it was discovered this year that the aurora on Jupiter transfer that energy through the atmosphere towards the equator, it was also discovered this year that the auroral excitement on Earth is transferred through the ionosphere towards the equator. Not so crazy to think both magnetic planets behave the same when coupling with the solar wind. And as those waves go through the ionosphere, which, if you recall, is the mesosphere and thermosphere we've been discussing, they are affecting the global electric circuit, which has a ceiling of the ionosphere and a floor of the atmospheric component all the way at the ground. This electric modulation of current through the pressure cells controls a bit of Joule heating in the atmosphere, but more importantly, the cloud conditions. The aerosols, dust, the vapor, they're all more attractive under higher electrostatic conditions, which also nudges the when and where of the rain as well. Now, when we come back to here, we have no choice but to tint that mesosphere a bit lighter blue. We won't go all the way white because there is that slight drop in the mesospheric temperature, and for now, they get to blame that on the increased CO2. But due to how much the sun works the ionosphere within the thermosphere and mesosphere, and how it works the ozone, and how it has influences throughout the atmosphere via the global electric circuit, close eye, bottom left, on the troposphere and stratosphere, we're going to go ahead and tint those a bit lighter blue. Not at the mesosphere level, but with just a handful of papers this year, building on hundreds from years before. We should begin to see how the chemical forcing paramount to the prevailing dogma is becoming a bit caged in. In part 2, we're going to open that cage, but right now, let's go back and answer the one question we didn't answer in the video. Where is that extra increase in the polar summer mesospheric echoes coming from if it's not likely to be CO2, and if they already took out the solar and geomagnetic forcing and will play devil's advocate and say they did a good job and they did manage to take out all of it? Well, it's an easy one explaining the surplus. Earth's geomagnetic secular variation is to blame. After centuries of slow meander, the magnetic poles began their next excursion in 1859, the same year as the Great Carrington Event solar storm. In the year 2000, the field had shifted considerably, and we had lost 10% of its strength. That number was updated to 15% in the year 2010 by the ESA, and in 2014, the trend was confirmed, and we learned that what had been a 5% loss in the field per century was now 5% per decade. In 2019, the field was changing so rapidly that they had to make an emergency mid-cycle update to the global magnetic field model so that there weren't critical GPS problems for things like aircraft. This is a very bad sign for the magnetic field of our planet, as the models had never failed to this degree within just a 5-year update cycle. The weakening field is allowing more charged particles and over-electrification of the upper atmospheric layers, which is one of the key ingredients of polar mesospheric summer echoes, and noctilucent clouds, which makes one ask about their recent record activity as well. And a final ask is this: if the extra CO2 has unquestionably invaded the thermosphere, how could it not have had any effect on the temperature? And what does that tell us about the CO2 chemistry they're using at the lower layers of the atmosphere? Whenever you're watching this, I'll see you in the morning for the daily update. Be safe, everyone.